And I'd like to show you where I work. That's it down there amongst the trees. The Perth Observatory, located in Bickley. Why all the way out here on top of the Darling Scarp? That's because the observatory needs to be as far away from city glare as possible, and the cleaner air helps a great deal. This site is also good because it allows our telescopes to view significant events in the night sky not visible anywhere else in the world at this moment. But the Perth Observatory wasn't always located at Bickley. Originally, it was situated just outside Kings Park. So, if we're going to look at the Perth Observatory, that's the best place to start. The original observatory was founded in 1896 and occupied this building. The move to the new site occurred in 1964. Since then, these offices have continued to be used, and today the building itself is the headquarters of the West Australian branch of the National Trust. In its heyday here, the observatory had only 3 telescopes. These were the original Meridian telescope, which is now stored at the new building, the US Naval Observatory's 30-centimetre reflector telescope, which is on loan to the Amateur Astronomical Observatory in Kalamunda, and the only original telescope still in use at the Bickley site, the astrographic telescope. From up here on the tower, you can see where the astrographic dome used to be situated, now replaced by the Public Works building. Although it's close to 100 years old, the astrographic is still operational, and to find out the sort of work it does today, we'd better go to Bickley. Isn't television great? Pictures taken by telescopes have always been important in studying the night sky. These pictures can be photographic prints, or, in the case of the astrographic telescope, photographic plates, like this one of the half moon. The astrographic telescope, like most professional telescopes, has a small motor and gear system to move the telescope slowly to compensate for the Earth's rotation. Originally, the astrographic telescope was used to obtain star positions. These days, its main purpose is to take plates of objects such as comets and minor planets. A recent and unique addition to this telescope is this plate camera, made in the observatory's workshops. This moves the plate so that it accurately follows the path of these objects, producing a much clearer image. Exposed plates are taken to the main building to be developed in a similar way to normal black and white photographs. The observatory has 2 main dark rooms. This one used mainly for developing photographic plates, and the other for developing negatives and prints. As in black and white processing, the plates are loaded into a solution of developer before going into a stop bath and then into fixer. When the plates have been processed and measured, they're put in here for storage. These two are interesting. This is of Comet Halley when it appeared in 1910, and this of the 1986 appearance. The reason we keep all of these plates is to check for changes between successive plates. To view these, we need a light table. This allows us to inspect an image on the plate. Of course, to make accurate measurements, we need more than a simple light table. This machine is capable of measuring the light emanating from a celestial object thousands of light years away. Of course, there is more than just the astrographic telescope here at the observatory, and there are other ways to gather and store images of the heavens. This 41cm telescope belongs to the University of Western Australia and has been located at the Perth Observatory since 1969. At the moment, it is equipped with a filar micrometer, which is used to measure double or binary stars. The important thing to remember about a telescope is that it is like the prime mover part of a semi-trailer. That is, it does the work, or in this case, of bringing an image closer, while the apparatus on the back can be exchanged to suit the job required. The operation of a meridian telescope is quite different from that of other telescopes, because the meridian can only look from the point due north on the horizon through straight up down to due south. In this way, it checks the positions of stars and planets which pass across its line of sight. Working out here at night can be very cold, particularly in winter, so observers have to wear special thermal suits. Heaters cannot be used in the dome because they would disturb the air and severely reduce the accuracy of the measurements. While one observer looks through the eyepiece, adjusts the telescope and starts the observation, the other notes down the number of the current star and finds the approximate location of the next star to be observed. From the accurate star positions gained, optical and radio astronomers can correlate their observations, and the structure of the galaxy can be studied. Space industries also use this information to position communications and weather satellites. All astronomical observatories must have access to an accurate timekeeping system because almost all calculations depend upon the time at which a particular event in the sky took place. The large amount of data gained from the telescopes has to be processed before it can be used. For this reason, computers are necessary to process and store the information for future access. This means that observers and astronomers must understand these machines, and particularly the mathematics involved. To astronomers, mathematics is of crucial importance because it is used to describe the movements of stars, planets, and other objects in the universe. It's no easy task to keep a place like the observatory running smoothly. The technicians must repair and replace equipment as quickly as possible. Often parts must be customised or created from scratch to maintain the telescopes, the domes, and the complex machinery used here. The observatory also has a library on the premises. In here, staff and members of the public can study relevant published information gathered from other observatories and research institutions around the world. Some of the journals held here are very old indeed, such as the complete collection of Nature magazine, which dates back to 1869. Again, these are not kept merely for historical interest, but as a reference to material published by many astronomers over the last century or more. This, and all the other information gathered by the Perth Observatory, would be of little use if it were never made available. For this reason, the observatory has an important role in educating the Australian public as well as informing astronomers, both professional and amateur, worldwide. You might like to see the observatory for yourself on one of our daytime tours. Just give us a call to find out more about them. We also have regular night tours available to small groups. These are very popular because they give the public the chance not only to see astronomers at work, but also the opportunity for them to see the night sky through the observatory's 36cm Celestron telescope. The tallest and perhaps most impressive structure at the observatory is the Lowell Dome. Let's go and take a look at it. On top of this 23-metre tower sits by far the largest telescope in Western Australia. It arrived here in 1971 on loan from the Lowell Observatory in the United States. With its 61cm mirror, its original role was to study the features of the planets Jupiter and Mars. These days, the Planet Patrol project, as it was called, has been replaced by space vehicle exploration, and the loan of the telescope has been extended to allow the observatory to continue with its own research. Just before the recent encounter with Comet Halley, the University of Maryland sent us a new form of digital camera called a CCD, which stands for Charge Coupled Device. The heart of this camera is a small silicon chip which turns the light gathered by the telescope directly into a digital picture. With the housing removed, it's possible to actually see the chip itself. It is important to cool the unit before it is used, as this helps to increase its sensitivity. The easiest way to do this is by pouring in liquid nitrogen to surround the chip. The information from the camera is then fed into a computer, which can display the image on a monitor or store it on a computer disk or magnetic tape. The computer can also manipulate the information so as to gain an insight into such things as the chemical composition and structure of the objects in the image. From all this information, the Perth Observatory, along with other observatories around the world, is gathering information about the universe and in turn the world on which we live. The human race has always looked at the night sky with a sense of awe, and here at Bickley, as the sun slowly sinks behind the horizon, a small group of people are again turning their eyes to the heavens.